Satellites have revolutionized the way humans communicate, explore space, and understand the universe. From their initial role in military and scientific endeavors to modern commercial applications like GPS and telecommunications, satellites have become a crucial part of life on Earth. This article explores the history of satellites, from the launch of Sputnik 1 to the advanced satellite technologies of today. The idea of artificial satellites can be traced back to science fiction and theoretical works. In the late 19th and early 20th centuries, writers like Jules Verne and H.G. Wells imagined objects circling the Earth in space. However, it was not until the 1940s that serious scientific discussion about satellites began. One of the most notable contributions came from Arthur C. Clarke, a British science fiction writer and inventor. In 1945, Clarke proposed the concept of geostationary satellites in an article titled Extraterrestrial Relays. He theorized that satellites placed in orbit at a specific altitude could be used for global communications, an idea that would become a reality decades later. The space race between the United States and the Soviet Union during the Cold War drove the first major advancements in satellite technology. On October 4, 1957, the Soviet Union launched Sputnik 1, the world's first artificial satellite, from the Baikonur Cosmodrome in Kazakhstan. Sputnik 1 was a small, spherical satellite equipped with a radio transmitter, and its beeping signal was detected by radio operators around the globe. Though the satellite's mission was simple, the launch of Sputnik 1 was a profound moment in human history. It demonstrated that humans had the ability to send objects into orbit around Earth, sparking a wave of scientific and technological innovation. The success of Sputnik 1 also fueled the space race, leading the United States to intensify its space exploration efforts. Shortly after Sputnik 1, the Soviet Union launched Sputnik 2 on November 3, 1957, carrying the first living organism into space, a dog named Laika. Although Laika did not survive the mission, Sputnik 2 represented a significant step toward human spaceflight. In response to Sputnik, the United States accelerated its space program. On January 31, 1958, the U.S. launched its first satellite, Explorer 1, designed by the Jet Propulsion Laboratory, JPL. Unlike Sputnik, which primarily served as a political demonstration, Explorer 1 had a scientific purpose. It discovered the Van Allen radiation belts, regions of high-energy particles surrounding Earth, marking the beginning of scientific satellite missions. That same year, the U.S. government established NASA, National Aeronautics and Space Administration, to oversee the nation's space exploration efforts. NASA's early satellite projects included communication satellites, weather satellites, and space science missions. As satellite technology advanced, new applications began to emerge. One of the first major breakthroughs was the development of communication satellites. In 1962, NASA launched Telstar 1, the world's first active communication satellite, which enabled the first live transatlantic television broadcast. Telstar 1 proved the viability of space-based communication and laid the foundation for the global satellite communication networks we use today. Around the same time, satellites began to play a crucial role in meteorology. During the Cold War, satellites became a critical tool for military surveillance and intelligence gathering. Both the U.S. and the Soviet Union developed reconnaissance satellites to monitor each other's military activities from space. These satellites, often called spy satellites, could capture images of enemy territory, track missile launches, and collect data on military installations. One of the most notable military satellite programs was the U.S. Corona project, which began in the 1960s. Corona satellites were equipped with high-resolution cameras that could photograph vast areas of land. The film was then physically dropped back to Earth and retrieved by planes. This program provided the U.S. with crucial intelligence during the Cold War. Satellites also played a key role in human space exploration. In 1961, Soviet cosmonaut Yuri Gagarin became the first human to orbit the Earth aboard Vostok 1, a mission made possible by satellite technology. The United States followed with the launch of Project Mercury, which sent the first American astronaut, Alan Shepard, into space in 1961. In 1969, NASA achieved the monumental feat of landing humans on the Moon with the Apollo 11 mission, a triumph that was supported by a network of communication satellites that allowed real-time transmission of the historic event. Satellite technology has continued to support human space missions, from the International Space Station, ISS, to future plans for Mars exploration. In the 1970s, satellites began to revolutionize navigation and global positioning. The U.S. Department of Defense developed the Global Positioning System, GPS, a satellite-based navigation system that allows users to determine their precise location anywhere on Earth. The first GPS satellites were launched in the 1970s, and the system became fully operational in the 1990s. Today, GPS is used in a wide range of applications, from smartphones to military operations. In addition to navigation, commercial satellite services expanded rapidly. Telecommunications companies began using satellites to provide television, internet, and phone services worldwide. The launch of Intelsat 1 in 1965 marked the beginning of commercial satellite communication, and by the 1990s, satellite TV and internet had become widespread. Today, satellites are an integral part of modern life, used for everything from environmental monitoring to space exploration. Earth observation satellites like Landsat and Sentinel provide crucial data on climate change, deforestation, and natural disasters. Meanwhile, space telescopes like the Hubble Space Telescope have provided unprecedented views of distant galaxies, black holes, and other cosmic phenomena. Satellites have also enabled the exploration of other planets. NASA's Mars Reconnaissance Orbiter, the Voyager missions, and the Juno spacecraft are all examples of how satellite technology has extended humanity's reach into the solar system. From the launch of Sputnik 1 to the modern era of GPS and space exploration, satellites have transformed our world. They have changed the way we communicate, navigate, predict weather, and explore the universe. As technology continues to evolve, satellites will undoubtedly play an even greater role in shaping the future, helping humanity tackle global challenges and reach new frontiers in space.